Okay, then okay, so this is your input of the reference, sorry, input of the modulator. So this one we apply the marks block, because we need to what we call it, maybe we need to compress the two signal. So then this signal actually carry two information, VD and VQ. Okay, so this is the sample and hold. Yang ni you retain je. Okay, ni, so you double click this block. So make sure you change the sample time must be 1 divided by 1000, because based on the question kan, information given, the design requirement, first it requires you to design the switching frequency 1 kilo. So mean the switching frequency is determined by the triangular frequency. So that's why you need to set the sample time must be inversion of the triangular frequency. 1 divided by 1 kilohertz. Okay. Yang ni dah buat So then this one you okay, yang ni 1 kilo. Sorry Here will be 1 kilo. Okay, so you can open this block. Okay, this block actually you can obtain from here. MATLAB function. I think from under Simulink library, you go to the user defined function. Maybe here. MATLAB function, mana? MATLAB function, this one. Okay, you can take out the block from here. Okay, you just take out. Okay, ni. Okay, you can double click the block to open the block. Ni, nampak So you can set the name of the function block as SV_modulator. So this is the step based on the flowchart. So firstly, you need to define the input. So where the input is the VD and VQ. Input of the modulator is VD and VQ. Okay, then you need to calculate the magnitude and the angle. Okay, then you detect the sector, calculate the alpha, angle within the sector, calculate V alpha and V beta. So based on the derived equation that we have derived last time. So then you apply the equation to calculate the TA, TB and TZ. Calculate the duty ratio, then finally you can generate the output lah, which are the duty ratio. Okay, we go step by step. So actually to develop the model, you must have tool lah kan. So the first, you must know how to use the tool. For example, the MATLAB. Same like you use the calculator. If you know how to use the calculator, okay. Then the second one, the theoretical. The theoretical based on the what we have discussed in class. Okay, so okay, untuk first step, you have to initialize the control parameter values. Jangan nampak ni. Let me open this file first. Ini answer, sorry. Mana bawa keluar ni? Kita keluar jawapan lah. Where is the... Okay. Macam mana nak keluar ni? Sorry. I need to open to new window. Macam mana buat new window ni? Susah juga ni. How to... Sorry. Maybe saya kena copy paste dekat Word file. Sebab dia tak boleh split the window. So this is the answer. Okay, sorry. Okay, now. Okay, this file. Okay, first you need to initialize the output. The control parameter. The control parameter. So means here, based on the question given, your VDC, you set the DC voltage is, what is the value? 120 volt, right? So this is the first line instruction. So make sure after you write the instruction for each line, you must put the semicolon ni. Semicolon. Semicolon mana nama dia? Okay, semicolon. So you define the DC voltage, then you define the switching period, which is T. What is the T value? T is 1 divided by switching frequency, 1000. Okay, then apa? Okay, so you may write the comment. So here maybe you can write the comment. So to write the comments, so you must type the percentage symbol here. Percentage symbol, then you give. This is instruction for initial value. Initial value of DC voltage. Ataupun this is the DC voltage. This DC voltage value. So then T is the switching period. T is the switching period. Apa lagi? Alpha BDVQ Z. Then okay. Then you go for the second comment here to define the inputs. Okay. So your input, if you look at the model. Aduh, pening betul lah. The model here. So you have VD and VQ. Right? Means this signal, this line signal carry two information. VD and VQ. Okay, so your VD is U1. VQ will be U2. Okay, sebab you pakai marks ni. You ada U1 and U2. Okay, so here. Okay, you set your VD here. Your VD, the D component of voltage is U1. So don't forget to type ni, semicolon. And VQ. U2. Semicolon. Depends, it's okay. You boleh put small letter or capital letter. Okay, then next step, you calculate the magnitude and the angle. How to calculate the magnitude and the angle? Alamak. Betul ke ni? So to calculate the magnitude, V is equal to what? How to write? Square root VD power of 2. This is how you write power of 2. A symbol what? Head symbol kan? Plus VQ squared. Semicolon. Good assignment, boleh discuss together. Okay, then VD, VQ, sorry, the magnitude to calculate the angle. So angle we define as theta. Theta, which is equal to okay, arctangent. This one is arctangent. So VQ divide by VD. Semicolon. So kalau kita refer based on that we have discussed yesterday. Mana equation? Maybe saya kena kecil sikit ni. Where is the equation? Which one? Which one? To calculate the magnitude and angle. Tak ada. Maybe saya boleh write the note here. So your input of the modulator This is your SVM, the modulator where the input are VD and VQ. So now, so remember D and Q, because your space vector, you drawn the space vector in DQ axis. It's not the alpha beta axis, DQ. So this is the angle that we need to calculate, and this is your space vector where the space vector is consists of the magnitude and angle. Okay, so from here you can calculate the magnitude as ni kan. Ini simple je. Right? Angle is tangent minus 1 BQ divided by BD. So you apply these two equation and to write the nilai instruction. Okay, clear eh? So maybe you can write the comment here. So mean this line instruction is the magnitude of space vector of V. I just put V. Then this is angle. The angle. Right? Why? Oh. So make sure you put the percentage symbol eh. So mean we define this as a comment. The angle of V. So the angle is in what? Degree or radian? In radian. So maybe we can check. How to check? Yeah. Okay, so you just jump to the last line of the instruction here to define the output. The output. So means here SV, because the function MATLAB name is SV underscore modulator. Here we put V, comma, theta. Okay, we check first. Macam ni nak buat ni? Betul lah? Oh ni je. Betul ke? Saya pun try error ni. Okay, so make sure this name same with the ni that we have defined here. You kena consistent dia punya nama, the name of the function SV underscore modulator. So means here to define the output, so you must write the same name ni, SV underscore modulator. So now the outputs are two. You have the magnitude and angle. So we need to verify, is it the angle in radian or degree? Okay, so then we can try to simulate. Try to simulate. Mana tadi file mana satu ni? Sorry, where is the file? Here. Okay, so before you simulate, because the block, you have one input and one output. So mean this block, because this line actually carry two signal. You have two inputs, the magnitude and angle. So mean here you need to demarks. You need to apply the demarks block. Okay, demarks ni. Here. Single input, then it can produce two output. For marks, multi-input, single output. For demarks, single input, multi-output. Okay. So you take out this block. Go to here. Boleh. Okay, then you can observe the waveform. Cuba cari ni, scope. You take out the scope. Ambil scope. Scope magnitude. So this one, this is for the magnitude, here for the angle. Okay, try run the simulation. Is it okay? Takut tak boleh run. Yeah, yang ni maybe you need to extend the stop time here. Sorry, the stop time. Okay, the stop time you change from this value to maybe you need to plot for at least 2 cycle of the waveform. Because you set your punya frequency here, VD and VQ is 50 Hz. So mean the period is 0.02 second. Okay, yang ni you maybe 0.02. We try to plot for at least 3 cycle, 3 complete cycle, you times 3. Or maybe you can write 0.06. Faham? Kita nak analyze for 3 complete cycle of the sine waveform. Okay, simulate. Lambat pula. Why it takes so long time? Lama Kenapa ambil masa lama? Cepat tak punya? Lambat Sorry. Pasal aku tak prepare ni. Betul lah. Yang ni cepat. Kenapa lambat ni? Satu 10.8. Okay, Afiq. Simulate okay, laju. 12% now. Macam mana bila ada inverter lagi cepat? This one okay. 1/10.8. Pelik pula. Lambatlah simulate. Boleh dapat? Okay. Dapat pun. Aduh. Okey.
Want to open it? Oh, ich gebe in error. Do not open source package.
This one is 2020, but should be okay because the original file from 2020 and lower version.
Do I have to download some
I don't know.
extra packages or something?
But for resource okay. Last
Yeah.
time,
The other one is okay.
I mean the product is okay. You install complete product. Try open. Where is the file? Can you show me the file? This one. Maybe you try to create folder, one folder. Okay, you put here, right? This one you put here.
Just drag and drop.
You create one folder, special for the assignment.
I don't have Teams on this PC. You just have it on my iPad, and then send the
iPad, okay. Maybe I advise you. You put this file in your computer directory.
it is in my computer. It's in
Okay.
downloads.
Okay, download. No, you just create folder for the assignment. You cannot share to the download folder.
I have to open it directly from the Teams.
Yes.
Yeah, then I have to log in. That's right.
Susah betul lah buat benda ni. Nampak juga. Sorry, because I do not prepare to this one. Maybe I need you to speed up the simulation. Maybe you need to increase the sampling time. Wait. I try. Sorry. 1 here, 5 micro.
As an output, we have to see
0. Let me check this one first.
Yeah.
Okay. Okay, class. Sorry. Okay, in order to speed up your punya simulation running time, so maybe you need to remove this block. What block? The sample time. This one. You just remove, just bypass this line. Boleh? Buang dulu. Before this, the block is what? Saya pun dah tak ingat dah. Control Z. Okay, so please remove these two blocks. Okay, boleh? Okay, you delete. This one also delete. Then connect directly. Okay? So then, satu lagi, maybe you need to change. Okay, one thing you need to change the sample time. Sebab kita nak speed up your punya running simulation. Kalau tak, it will take longer time to complete the simulation, to running of the simulation. Okay, you click this model setting button. Click this model setting button. Asal tak bunyi ni? Then dia akan pop up this window. Okay, change the fixed step size from 0.01 micro, change to 5 micro. 5 micro. Sorry lah Ini, you click this button. Go to the modeling tab. Make sure you click the modeling tab. Boleh? Click this model setting button. Okay, then you change the fixed step size to 5 micro. 5 micro. Okay, one thing, stop time we set 0.04. Means it just analyze the cycle. The cycle of the waveforms. Okay. Change to 5 micro. Maksud dia your punya sample time dia akan lebih panjang. So mean dia akan speed up your punya ni simulation running time. Okay. Okay. Okay, then click OK or apply. Okay, then you can run the simulation. Try run the simulation. Cepat kan? So this is the result. Mana waveform tadi? Here, the magnitude and the angle. Okay, but so the first step is I want to teach you how to use the tool. First, you have live. You know, okay. So make sure your waveform, the magnitude is 50 volt, constant at 50 volt. And the angle varies from 5 to -5. So indicating that the progression of angle in radian. Dia bukan in degrees, radian. Okay. That's it, bro. No, scroll down. I'm going to see the real function. Open the real function. Okay, scroll down. Monitor. Jadi we have to change the setting here. So now use external signal. Very important. Use no signal. If you want to apply this technique, you will subtract from the clock. The clock is the time. Yes. Even Okay, anyone? So maybe you can proceed. Move forward. The other stages. So calculate apa? Alpha and so on. Look at the sector. So you got to change. Okay. Here, 50 also 5L. Here, so boleh selesai dia. 90 degrees. Kita kerja. Transmission. Ini 50 now, 50 based on calculation kan. Okay, you may proceed to do the next part to calculate the alpha, detect the sector. Okay, okay, dah. Okay, so you can notice here your angle is varies from pi to minus pi. So mean the production of angle in radian. It's not in degrees. So how to get the angle in degrees? So you need to do the conversion from radian to degrees. Then what? How to convert from radian to degrees? Okay, so means here your theta. So maybe you can write here. you set the variable name as theta degree. Okay, theta degree equal to theta that you have calculated above multiply by what? How to convert from radian to degree? 180 divided by pi. Okay, now you can see. Here maybe you can set the output now degree. Just to check. Alright. Okay, run the simulation. Why not run? Okay, sorry. So then you can run. Where is my file here? Okay, you run. So this is the magnitude, 50 volt, same. The angle now varies from 180 to minus 180. Okay? Then you can also convert from radian to degree. You dah understand tak? You kena write this instruction. Ni. Put another them, theta underscore degree. Sebab kita nak differentiate kan, theta in radian, theta in degrees. Okay. Output you kena set the output kan, theta degree. Sebab yang saya you set theta for radian, tidak output. Kan? Sebab you keluarkan dalam radian, sama dia tadi. Okay. To mean your output now, okay, this is your output signal kan. Ni, sorry. Okay, so means where's the okay. Okay, so means your punya output theta degree. Okay, remember so for V1 the angle is 0, right? Here is 60, 120, 180. So mean your reference starting from here, they rotate, right? They rotate and rotate to form a circular locus from 0 to 180. So mean from 0 here, my cursor ni varies to positive 180, right? So since your reference continue to running, nampak? So mean here positive 180 suddenly change to minus 180. So that's why from the waveform, suddenly the waveform change from positive 180 to minus 180. Nampak? Masa dia trajectory and dia move from sector 3, then just enter to the new sector 4. Nampak? So that's why your angle suddenly change from positive to minus. Okay. Okay, now next step, how to detect the sector. So tengok, based on this diagram, you have 6 sector. 1, 2, 3, 4, 5, 6. So mean you need to set the output sector. So you must create new variable for the sector. So when you not detect the sector, how to detect the sector? You dah study for C programming kan, micro P class. You can apply if else. Macam mana buat? Okay ni, detect the sector. Next step. If theta underscore degree larger than or equal to 60. Close bracket. And double N symbol. So you have two conditions. So the first condition, theta degree larger than or equal to 60. The second condition, theta underscore degree less than 60. Sorry, ni salah. Okay, sorry, this one is 0. Theta degree. But you nak compare in degrees. Mana? Okay, sorry. Theta. So if these two conditions fulfill, sebab you ada operator and no, means both condition must be satisfied or fulfilled, dipenuhi. So then the sector will be sector will be 1. Okay, refer to this diagram. If your theta degree, so means your reference now. Ya, saya padam. If your reference, something here kan, your theta is larger than or equal to 0 and theta less than 60 degrees. So this is 60. Here 0. So then the sector will be sector number 1. Okay. Okay, then sector 2. Write the condition, sector number 2. Kecilkan sikit. Else if. You can buy else if Copy lah senang. Lambat. Okay, apa benda ni? Theta degree apa? Larger than or equal to 60. And degree 120. So this will be sector. And tu adalah shift 8 tu, shift 8, shift 7. Kita buat assignment sama-sama dalam kelas ni. Okay, for sector 3. What are the condition? Theta degree 120. But must less than macam mana ni? Sector 4. Sector 4 buat sendiri. Try and error. Then try you verify your result by plotting the waveform. Part 56 Okay. Buat sendiri. Faham kan? Saya yang tadi tanya kawan particular. Okey. Dapat. Yalah, check lah. Okay, how to detect sector 4? So since the angle is negative value. So you can imagine now your reference will be here. To detect the sector lies in sector 4, this sector. So mean your angle should be what? Larger than kan? 180 degrees. Which one will be larger? 150 or minus 180? So this case is 150. Betul? Negative 150. Larger or smaller than ni? Should be larger, right? So mean ini first condition. And the second condition must be less. Less than what? So here will be what? V5 angle, what is the angle for V5? 120. Right. V6 60 minus 60. Betul? So means this second condition, the angle should be less than 120 degrees. So if these two conditions are fulfilled, so means the sector in, we detect the sector in sector 5, sector 4, sorry, sector 4. Okay? Tengok waveform ni. Look at the waveform here. So maksud dia you punya angle now dekat sini, somewhere else here, right? Between minus xt to minus 120. Betul dekat sini. So mean when the angle here, the range here, so mean the vector is located in sector 4. Betul eh? Okay, then you write here will be minus 180 and the theta degree must less than minus 120. For sector number 5, ini terbalik. Aduh, macam mana kita? Minus 180. Here, what? Minus 20. And theta degree must less than minus 60. Tenang ini. Minus 60 and must less than 0. Betul eh? Okay, so let's check the output. So maybe we can put additional output. Okay, your output now here, you have V theta degree, and just put another one, which is sector. We try to relate and the punya waveform of angle tadi, the theta degree and the sector. Okay. So you put another output, the sector, SEC. Kalau you nak put apa full name tak apa, sector kan boleh. So yang ni pun you kena letak nama penuh, sector. Okay, then we try to verify the output. So means here, you kena add additional output. You double click the demarc block. Demarc block ni double click. So now you kena add from 2 to 3. Because your output ada 3 kan, the magnitude V, theta in degree and the sector. So change to 3. Maybe you can resize in this block. Right. Okay, maybe macam mana boleh? Macam mana ni? Okay, sorry. Maybe you just retain the output here. Macam tu ke? Ataupun ini you set here. Okay, sorry, this one you change to 2. Because we need to compare the degree, the theta and the sector. You just select for 2 row, 1 column, 2 row. So mean the scope have 2 graph. Two graph lah. Cuba tengok. Okay. Nampak dia jadi begini. So the top graph to plot the theta in degrees. The second graph, the bottom graph to plot the sector. Boleh eh? Ni cara setting ni, you double click the setting button here. Then change from 1 to 2. Layout, you drag sini. For 2 row of the ni lah. Okay. Okay, then here, you connect to the second input of the scope. Right. Okay, then you need to run the simulation. Run the simulation. Okay, error. Alamak, ada error. Why have error? It's not assigned. Okay, let me try first. Sector. Here, sector is okay. So maybe you need to initialize the value of sector. So let me try first. 0. Okay, maybe 1. Because it doesn't have sector 0, sector 1. Just put for any number of sector. Try to run. Is it okay? Error. Mana? This one okay. Apa dia punya error ni? SV modulator is not assigned. Line 3. Sector. Okay, sorry, you kena put N ni. You kena complete with N instruction. You ada if else, so yang bawah so you kena put N. Right with N. Cik baik. Okay, now success. So then you can double click. Check the waveform. Ya. Saya bagi tebal sikit. Ni, you kena put ni last line of instruction if else ni, N. You belajar C kan? You kena complete dengan if else with N. N instruction. Boleh? Saya cuba tunjuk. Okay, check your punya result. So you can check, is it right? Here, -5, right? Go to minus, maybe under 20. So this will be sector 4. So you can refer from the diagram as we show. Okay, boleh sikit lagi. Okay, please compare your output, your simulation result with this diagram. Nampak? Nampak So when your kacau lah. For example, your reference vector located at this point, this one. So means between 180 minus to minus 120. So mean kat sini kan? Betul? Check. Okay ke lah boleh So when you check, your punya angle ni varies between minus 180 to minus 120. So mean this will be sector ni. What sector? Sector 4. Sector 4 ni. Lepas tu kalau dia varies between 120 to minus 60. Ni kan kat sini kan. So this will be sector 5. Sector 6 from minus 60 here, ni minus 60 ni, to 0. Minus 60 to 0, nampak mouse cursor saya? Minus 60 to 0. So mean we detect the vector lies in sector 6. Kalau 0 to 60, 0 to positive 60 here. So this will be sector 1. Sekarang saya buat sendiri. Okey, buat makan.
Mana dia punya ni?
Ini tu tak buat pun.
Dia belum ni kot. Belum kot.
Kita nak buat.
Belum. Doktor
Tak,
kata
tak,
belum.
tak.
Tak ada. Moh tak ada ni.
Ni.
Mana moh ni?
Di sini mau. Ni
Tak, tak.
ni. Ini kecil kan.
Atas sini.
Ni dah.
Oh ni empat ni. Ni satu sama satu ni. Ni nampak ni. Ni satu dengan satu. Pause sekali.
Okay class, so don't forget to put the initial value of sector here. Kalau siapa those yang familiar to program using DSP board, and in your programming you must set the initial value of the control parameters. So same goes for the mainland. You're going to set the initial value. Okay, next step. And a very important step to calculate alpha within a sector. Okay, so this case we let the alpha. So you must set alpha must be in radian. Right? Okay, so we define alpha. The value must be in radian. It's not in degrees. Okay. Okay, how to obtain the alpha, to calculate the alpha? Okay, let's say your vector now located in sector 1. So you must write like this. Double ni. Equal symbol that. Sector double equal symbol 1. Enter. So this case your alpha will be what? Someone give the answer. Your alpha will be theta degree or theta. So you must set alpha in radian. So your alpha will be theta. Okay. So means here. So let's say, let's say erase first. Let me erase first. This one very important for your midterm next week. How to calculate the alpha for every sector. Kejap Lepas ni boleh buat balik rumah. So this case, if your V located in sector number 1, sector number 1 ni. Okay. So if your V located in sector number 1, so firstly you need to identify what is the VA. The first adjacent vector to be selected within a switching period. Someone give the answer, V1 or V2? So V1. So mean your V1 will be VA. So remember the definition of alpha. First is the angle within a sector. Then you need to define the alpha is the different angle. And the different angle between the reference vector and VA. So mean your alpha will be here. Right. So mean this case, your alpha will be theta. So remember, theta you calculate in radian. Theta degree in degrees. Okay, now sector number 2. Jangan apa? Else if. Sama macam tadi, else if. Else if. Sector pula. Sector. Double ni 2. So your alpha. So what is the alpha? What is the alpha? In this case, I draw in green color ni. So now for sector number 2, your alpha may be located here. Mana nak buat ni? And sorry, dia tak boleh larger than. So this is your reference. This is your reference now. For sector number 2. So where is the alpha? You ada here 0 in radian V1 angle is 0. V2 angle is what? Apa? Pi per 3, right? Pi per 3 Pi per 3 is 60 degrees, right? 180 bagi 3, 60 kan? For V3, 2 pi per 3. For V4, positive 5. Ataupun kat sini minus pi dekat boundary ni. So here will be minus 2 pi per 3. So 60 degrees minus pi per 3. Okay, now if we discuss ni, we consider the V located in sector number 2. So someone give the answer. What is the alpha? So you need to apply this definition. Alpha is the different angle between the reference vector and VA. So for sector number 2, VA V3 or V2? Sorry, padam. So V3, right? So the angle here, VA is V3. So mean your angle will be the difference between the reference vector V and V3. So this is your alpha, ni alpha. Nampak? So macam mana nak calculate the alpha? So you nak kena isi kat sini ni. You have to write the alpha here. 2 pi per 3 minus theta. Macam mana nak buat? 2 kali pi divided by 3 minus theta. Okay, this for the sector number 2. Okay, clear? Okay, then you can proceed for sector 3 and so on. Biarkan. Sector 3. Macam mana sector 3? Okay, here I use what color ni? The orange color. So now your reference here, the space vector. In sector 3. For sector number 3, your VA will be V3 or V4? V3, yeah, same. So mean your alpha we can define as the different angle between V and VA. So mean here lah. Okay. So this is your alpha when your sector when sector 3 lah, for the case for sector 3. So mean the alpha is the difference between theta and 2 pi per 3. Betul eh? Theta minus 2 pi per 3. Saya buat yang semua. Is sector 4. Sector 5. Sector 4 macam mana? Sector 4. How about sector 4? This is your reference. Your VA now will be V5 or V4? Your VA. V5. So V5 is the first adjacent vector to be selected. So where the alpha we define as the difference between the different angle between VA and the reference. So here, right? So this is your alpha, the angle within a sector. So mean for sector 4, macam mana? Sector 4, macam mana nak write the equation? Sector 4. Minus 2 times pi per 3 theta. Betul eh? Theta. Sector 5. Macam mana sector 5? Theta. For sector 5 here. Orange color. So this is your reference. The adjacent vector will be V5. And so the alpha we define here. Right. Macam mana nak calculate the alpha? For sector number 5, the alpha is equal to theta Minus kan. Lepas tu you ada minus lagi kan. Right. Minus 5/3. Is it right? Clear? Betul, Afiq. You ada theta, so mean your theta will be here. Ni theta. Theta is defined from 0 to here. So this is the theta. So then you nak calculate the alpha. So the difference between theta and negative 2 pi/3. So you need 2 pi/3. Sorry, ini 2 pi. Sorry, 2 pi. Betul. Belakang tak nampak kan. Boleh? Ataupun you boleh simplify this equation as, sebab you ada minus kan. Then you simplify to positive. Okay, then last. Sector 6. Sector 6 straightforward je kan. As if sector 6. So your alpha will be what? So you imagine now your reference located here. For sector 6, VA will be V1. So the different angle between V and V1 here. Right. So mean here you can obtain as minus theta. Minus theta kan. Ya. Sebab dia ke bawah. Tak ada. Dia positif. So ni ada dua sorry, ni 2 times So make sure you write ni n for this function of ni. Calculation of alpha. Okay, finish until this stage. Calculation for alpha. So the next step, you need to calculate the V alpha, V beta, the on time, and the duty ratio. Now try do this one at home. Boleh? You cuba buat dulu. So maybe you boleh check lah. You set the input. Lepas tu you run the simulation. Then you observe the result. Then you check by calculation. Itu cara you nak verify your design okay or not. Boleh? Akan semua tunjuk kan. So make sure you complete and do the simulation. Next week, make sure you complete the simulation. So maybe big 12 or 13 and 14, you can come to my lab to run the software. Okay? Okay. So you can check, you can proceed to do the other stages. You make this step, you compare the application and the result. This is the result. So maybe you can the input given into this one. Maybe so then you run this system, you get the result, then you compare with apply equation that we have derived in class. The alpha beta just apply the equation. Very straightforward. Okay, class. So please do at home. Ni for the rest ni. Step N. calculation for V alpha, V beta on time. So refer to the tutorial that we have discussed yesterday. For example, this one. You apply equation V alpha, V beta, the magnitude, calculate you multiply with the cos function. Beta multiply by sine function. Alpha you have obtained already for the previous step here. Nampak maksudnya for this step, calculation V alpha, V beta, you apply these two equation. Very straightforward. So then you can proceed to the next step, calculate on duration, TA, TB, TZ. Apply this equation ni, TA here, TB, and TZ. Okay, you try simulate. You obtain the result, then you compare with the calculation. So maybe you can check your result to verify your design. Sorry. Okay, maybe you can remove this sine wave block. You substitute with the constant block. You compare the ni tutorial kan. Tutorial semalam kan kita buat ni constant kan. So your VD is maybe apa? Minus 50 kan. VQ ada value dia. Then you try run the simulation. You get the simulation result, then you check with the theoretical value, the calculation value. Kalau okay, so mean your design correct lah. Boleh? Simple. If any problem, you can come to see me at my lab. Ini assignment assignment cuma sendiri. Apa? Sebab dia varies between 0 to dia dah radian 0 to 5/3 we have the 5/3 kan. So maybe you can try to plot the alpha. So where your alpha will be varied between 0 to what? 5/3, 60 degrees. Nak plot lah, nak plot kan? Coding. Ini bisa apa?
Dekat ni kot. Coding.
Okey. Siapa deklar boleh ni? Boleh keluar.
Panjang langsung.
Panjang mana kan?
Buat kau apa?
Jawapan ni. Tak. Sekejap. Di sektor.
Bawah ni bawah.
try to complete installation tu dalam 2 minggu.
Ada declare.
Datang je jumpa.
Sini.
Ada doktor nak tengok kalau doktor declare
Dah?
yang
Alpha tu.
alpha tu. Ada.
Tu keluar kat ni.
Dia orang tak faham.
Yang kat sejarah
So, alpha
sekarang
ni
alpha ni
tengok kat mana ni?
doktor kan macam ni
Kan
kan.
saya lukis tadi tu.
Kayak sini kan doktor declare kan. Lepas tu yang nak tengok yang alpha dan alpha tadi tu doktor declare lah.
Tengok gambar yang saya conteng tadi tu. Mana tadi? Ni. Ni. Ya. Ni. Kan? Saya dah buat semua case, semua sektor. Kalau sektor 1. Alpha what ini kan nak define kan? Di mana alpha ni automatik sama dengan theta terus. Theta ni kan degree yang ni kan. Kalau sektor 2, okay, awak kena tentukan alpha ni mana satu. Cari BA dulu. Kalau sektor 2, BA dia ini kan. B3 kan.
Betul.
So alpha adalah beza antara reference ni yang hijau ni dengan BA. So awak tanda saya siap ni. Ni alpha dia. Okay, so maksudnya nak dapat alpha ni macam mana? Beza angle ni. Angle ni. Sorry, dengan angle ni. Angle hijau. Faham tak? Maksud dia 120 darjah ni. 120 darjah. Tolak dengan angle hijau ni. Yang theta ni.
Contohnya akan dapat yang
Theta ni kita dah kalkulate atas tadi. Yang menggunakan tangent tu.
So maknanya angle ni tolak angle ni akan dapat alpha yang ni.
Balik ni. Ni penting ni masuk test ni.
Okay.
Ambil gambar. Tengok. Cuba balik ni analyze. Ambil gambar ni. Ni penting.
Apa tu?
Design from scratch tau.
Apa ni? Ini dia.
Jom, paper je. Ni siapa punya air ni? Tinggal. Penat lah buat lab ni. Nak ajak Azura tolong lah. So nanti minggu depan test kan? Test buat kat sini. Muat ke lah? 70. Cuba kira satu meja ada berapa? Ada berapa meja ni? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Kalau saya nak buat
Meja 4.
sebab tadi pun kita duduk
Berapa rapat siapa? Bukan dua ni. Kamu masuk dua ni. Dua orang. Okey, kumpulan satu masuk dulu.
25 minit.
25 minit ni.
thank you masa sebentar
Dia kan boleh dah. Dia bukan online. Saya print dia dulu macam apa dia.
Tapi paper lah. Betul.
70 orang student ni. Tapi lepas tu saya ingat lepas test, saya ingat saya nak sambung buat benda ni. Besok minggu depan Isnin saya nak buat kelas rectifier kot. Nampak kan rectifier? Minggu sekarang minggu apa? 9 Buatlah cepat sikit habis. Lepas ni kita boleh concentrate buat assignment kan? Ya? Belum. Mungkin 3 kelas. 3 atau 2 kelas. So, Isnin ajar rectifier. Lepas tu Selasa buat test.
tapi saya tu tak rectifier keluar test sekali
Part 2. Saya pun tak tahu part 2 kot. Part 2. Lepas tu hari Selasa buat test. Lepas test tu saya ingat saya nak sambung buat benda ni. Biar minggu depan tu siap semua. Kalau Isnin kita buat kat sini pun best juga. Isnin buat habiskan ni. Isnin buat kat sini. Nanti saya tanya kosong tak? Kita buat kat sini. Selasa pun datang sini. Okey lah. Okay. Alright. Datang ya. Ni. Awak mesej saya dulu. Nanti saya lupa bawa barang. Awak mesej saya. Saya takut saya tertinggal barang. Barang komponen semua saya letak kat rumah. Okay.